Now let's go to the second part of chapter 12.7. Now in this part we are going to talk about spherical coordinate system. The spherical coordinates we have rho, theta and phi. We have three variables, rho, theta and phi, of a point in R3 three-dimensional space shown in the figure. Okay. So let's draw the three-dimensional space. We have three axes. This is the x-axis, y-axis and the z-axis. And now let's say we have a point in R3. This is a point in three-dimensional space. Then we define rho to be distance between the given point and the origin. So this distance is rho. Now if you project this point onto the xy plane, then let's say this point, this is the x value, this is the y value. Okay, now if you project this pink point to the xy plane, you will get this blue point. Now let's connect this blue point and the origin. Again, this blue point is on the xy plane. Now we define angle theta to be the angle between the positive x-axis and this magenta line. So this is your theta angle. Theta angle is very similar to the polar angle in cylindrical coordinate system. Okay, so we have defined parameter rho, angle theta, and then this phi is another angle. This angle phi is the angle between the positive z-axis and this green line. That's your angle phi. So let's write those things. Rho is the distance from the origin to the point in R3. So in general, rho can be greater than or equals to 0 because it's a distance. And angle theta is the polar angle. Angle phi is the angle between the positive z-axis and the green line. And let's do like this. The green line. Okay. So this is the way we define the three parameters in the spherical coordinate system. We have rho, which is a distance, and two angle parameters theta and phi. Now theta goes from 0 to 2 pi, and phi goes from 0 to pi. Phi goes from 0 to pi. So using these three parameters, we can define any point in three-dimensional space. Now let's talk about the conversion formulas. The x coordinate equals to rho sine phi cosine theta, y equals to rho sine phi sine theta, and now the c coordinate equals to rho cosine phi. Spherical to Cartesian, so rectangular, say. If you want to go other way, let's say you want to go from rectangular to spherical, we have x squared plus y squared plus c squared equals to rho squared, and y over x equals to tan theta, and then angle phi equals to inverse cosine or arc cosine c coordinate over square root of x squared plus y squared plus c squared. So this is the way we go from spherical to rectangular and rectangular to spherical coordinate system. It is better to memorize this identity. This is a very useful identity. X squared plus y squared plus c squared equals to rho squared. And rho is the distance between the origin and a point in the space. Okay. So this is the way we introduce the spherical coordinate system.